Today we are discussing about solutions of dual simplex method. Unit Unit 9. Solution by dual simplex method. Solution by dual simplex method. Dual simplex. The term duals refers to concepts the term duals refers to the interchangeability of a particular pair of terms. Interchangeability interchangeability of a particular pair of terms. Particular pair of terms. Particular pair of terms. The concept of duality is very useful. Concept of duality. It's very useful in LPP, linear programming. LPP means linear programming problem, as they provide solution to provide solution provide solution to challenging industry and marginal decision making issues. Challenging industry. Challenging industry. Challenging and managerial decision making issues. Making issues. Challenging making issues. So, procedure of dual simplex method or algorithm. procedure of dual simplex method. Procedure of dual simplex method. Step 1. The given LPP is minimized type. Suppose the given LPP means linear programming problem is minimized type. Minimized type. We need to convert or transfer, convert to maximize type. Maximize type. Maximize type. Step 2. Step 2. There exists greater than type. If there exists greater than or equal to type, convert less than or equal to type. Step 3. Step 3. Step 3. Express the LPP in standard form. Express LPP in standard form. SF means standard form. Introducing the slack variables. Introducing the slack variables. Slack variables. Slack variables. IFBS. Prepare the simplex form. Convert. IBFS. IBFS means initial basic feasible solution. Prepare initial simplex table. Prepare initial simplex table. That's by multiply by -1. Next place. Step 4. Step 4. Check for optimality condition. Check for optimality condition. Optimality condition. Case 1. Case 1. Case 1. If all dj greater than or equal to delta j greater than or equal to 0, if all delta j greater than or equal to 0 and xp greater than or equal to 0, 0, then current solution is optimal solution. Solution is optimality solution. Optimality solution. Case 2. If delta j is greater than or equal to 0, at least one of xb, delta j is greater than or equal to 0, and at least one of xp, at least one of xb less than or equal to 0, then the current solution is not optimal solution. Current solution is not optimality solution. Optimality. In this case, go to step 1. To case 3. So case 3. In this case, go to step 5. Yes, 3. Yes. If these exist, delta j will less than 0. If there exist, delta j is less than 0. Less than 0. For some tall j, simply. Then this method fails. Then this method fails. Yes. Step 5. Step 5. Leaving variable, outgoing variable. Leaving variable means outgoing variable. Outgoing variable. Outgoing variable. The leaving variable is basic variable. Leaving variable is LV, means leaving variable or leaving vector. Is a basic variable. Basic variable. Basic variable. Corresponding to the most negative value. Corresponding most negative value value, most negative value, XB, let, or XK as you wish. So entering variable means incoming variable. Entering variable. Entering variable means incoming variable. Incoming variable. The ratio between delta J ratio between delta J equal to ZJ minus CJ row and the key compute row and key row are compared and key row compared. Key row compared. Compute theta. Compute theta. Theta equal to max means maximum delta J equal to ZJ minus CJ whole divided by AIK. AIK. AIK is less than 0. Less than 0. Consider the ratio of the non-negative denominator. The entering variable is the non-basic variable corresponding to the maximum ratio theta. If there is no such ratio with a negative denominator present, then the problem has a feasible solution. So let step 6. Step 6. The procedure for simplex method is applied and repeated until either an optimal solution is obtained or non-existence of feasible solution is indicated. Difference between the simplex method and dual simplex method is in regular simplex method. In regular simplex method, we compute for entering the variable. We compute entering variable. EV means entering variable. Entering variable. Then decide about outgoing variable. Decide about outgoing variable. Outgoing variable. Outgoing variable. While doing dual simplex method, dual simplex method. We first determine outgoing variable. First determine we determine outgoing variable. Going outgoing variable. And then compute the and then compute for incoming variable in basis. In basis. In basis. Okay. Using these steps, we'll do one problem. Dual simplex method. Example. Use duality to solve the following. Use duality. Solve following. Solve the following. LPP. Mag Z. Mag Z equal to 6x1 plus 8x2. Subject to constants STC. 30x1 plus 20x2 less than or equal to 300. 5x1 plus 10x2 less than or equal to 110. And x1 comma x2 greater than or equal to 0. Comma x2 greater than or equal to 0. This is the question. Solution. So most important dual simplex. Because for 20 marks, solution, lengthy question. Solution. First, to convert the given LPP in primal. First, to convert given LPP in primal. So objective function. What is objective function? Objective function. Objective function. Max Z equal. Given in the question, this is max Z equal to 6x1 plus 8x2. So AX is less than or equal to B form. AX equal to B form. That means what are the STCs given? Subject to constants 30x1 plus 20x2 is less than or equal to 300 and 5x1 plus 10x2 less than or equal to 110 less than or equal to 110. Here, capital X means is nothing but x1, x2, right? Here, A equal to coefficients of x1, x2 means 30, 20, 5, 10. C equal to 6, comma 8 because these are the coefficients of objective function. Here, B equal to small b. B means what? 300. Equality. Inequalities 300, 110. Right. Now convert above primal problem. Now convert above primal problem into dual. Means dual. DUAL. Already we discussed this in chapter 7 and 8. How to convert. First introduce the number of dual variables. First we introduce the number of dual variables. Number of dual variables. Dual variables. The number of constants in the primal. Constraints in the primal. So here duals means W equal to W1 comma W2. These are the duals W1. No, let W equal to W1 comma W2. W1 comma W2. In primal we have two constants. In primal we have in primal we have two constants. In primal we have two constants. Two constants. Objective function. So objective function. No? Here what is max z? We need to write minimum z. Min z means minimize. Minimum z. That equal to minimum z. That equal to BTW. BTW equal to 300, 110, W1, W2. W1, W. So min z equal to means minimum z. Minimum z equal to 300 W1 plus 100 110 W2. 110 such that A transpose A transpose A transpose A transpose W is greater than or equal to C transpose C transpose. That implies matrix 25, 35, 2010. Then W1, W2. These are the positions of first equation. This is second equation. Is greater than or equal to C transpose. What is C? These are the positions of objective function. Positions of objective function. That implies 30W1 plus 5W2 is greater than or equal to 6. Next one, 20W1 plus 10W2 is greater than or equal to 8. Here, what are W1, W1 and W2 are duals which are greater than or equal to 0. For solving, first to convert or solving, first to convert, first to convert, first to convert about dual problems, about dual problem into SF. SF means standard form of LPP. LPP means linear programming problem, dual problem. So what is the dual problem? Dual problem. Dual problem. Min z, minimum z, min z equal to 300 W1 plus 110 W2. So STC, subject to constants, subject to constant. 30 W1 plus 5 W2 no, are greater than or equal to 6. 20 W1 plus 10 W2 greater than or equal to 8. No, where W1 comma W2 are products which are greater than or equal to 0. Form the LPP to about dual problem. Form the LPP. Form the LPP. About dual problems. About maximum Z. Max Z. That equal to minus of min z. Minus of min z. That implies max z equal to minus 300 W1 minus 110 W2. 110 W2. So subject to constants. STC. Consider equation number 1, equation number 2. 1 becomes minus S1 plus A1 6. 30 W1 plus 5 W2 minus A1. A1 means these are the surplus variables. Because greater than or equal to 0, now we need to subtract surplus. Minus A1 minus S1 plus A1 minus S1. Minus S1 plus A1. A1 is the artificial layer. A1 that equal to 6. Next, second equation becomes, this is considered equation number 3. Second equation, 20 W1 plus 10 W2 minus S2 plus A2 that equal to 8. Equation number 4 is considered. Next, so we need to write here S1 comma S2 surplus variables. So A1 comma A2 artificial variables. We need to find IBFS. That purpose, again, 3 becomes. It gives 30 W1 plus 5 W2 minus S1 plus 0 S2 plus A1 plus 0 A2 that equal to 6. Equation number 5. Equation number 5. Equation number 5. 4 gives 4 becomes 20 W1 plus 10 W2 plus 0 S1 plus S2 plus 0 A1 plus A2 that equal to 8. Equation number 6. So again we need to convert AW equal to B. Nothing but matrix form. Matrix form. Matrix. That equal to 30 positions of 5, nothing but 35 minus 1, 0, 1, 0. Next 20, 10, next 0, 1, 0, 1. That equal to W1, W2, S1, S2, A1, A2. That equal to 6, comma 8. 6, 8. So here 1, 0, 0, 1 is the unit matrix, and A1, A2 artificial variables, that equal to 6, 8. That implies A1 equal to 6, A2 equal to 8. Is the IBFS is called IBFS. That means initial basic feasible solution. So max Z that equal to minus 300 W1 minus 110 W2 plus 0 S1 plus 0 S2 minus M A1. A1 is the artificial value, M means maximum, minus M A2. So simplex table 1 we need to write. Simplex table. Simplex table. CJ means coefficients of CJ means coefficients of objective function. CJ. That means CB, WB. This is CB. WB. Generally, XB will write WB. Here, coefficient of objective function. What is that? Minus 300, minus 110. No? 0, 0, minus M, minus M. Here, minimum ratio. Min ratio. Min ratio. WB by WJ. WJ equal to W1. WJ equal to W1. WJ is greater than or equal to 0. That means coefficients W1, W2, S1, S2, A1, A2. A1, A2. Here, minus M, minus M means basic variable. CB is nothing but. Oh, here, W1, A1 means artificial variable. A1 equal to 6, A2 equal to 8. So, coefficients of equation number 5 and 6. So 30, that is 5 minus 1, 0, 1, 0. This one, 20, 10, 0, minus 1, 0, 1. So minimum ratio, WB by WB by WJ means 6 by 30. WB is 6, W1 is, so 6 divided by 30, that equal to 0.2. Next, 8 divided by 20, that equal to 0.4. So we need to take ZJ minus CJ. So ZJ minus CJ, that is Z star we need to calculate. Z star, how to calculate? Z star equal to sigma CB into WB. Sigma CB into WB based upon this formula. Minus M into 6. Minus M into 8. 8 plus 6 minus 14 M. Minus 14 M. Then this column, how to calculate? ZJ minus CJ. So minus, so how to calculate? Minus M into 30. Minus M into 20. 30 plus 20 minus 50. Minus 50 minus of 300. That is minus 50 plus 50M minus 50M plus minus of minus 300 means plus 300. Similarly, minus 5M minus 10 minus 15M minus 15M plus minus into 110. Next, like that, MM00, MM00. So what is the minimum ratio here? This is known as leaving vector LB. LB is the leaving vector. Most negative what is there here? This is EV, means entering vector or entering value. Intersect point is known as KE, means key element. Key element. Okay. Here, entering vector. Entering vector is W1. Next, leaving vector is A1. Next, key element. Key element equal to 30. So key element also known as pivot. This is outgoing vector, incoming vector. W1. So next simplex table. Okay. Next table. So simplex table 2. Simplex table 2. Simplex. R1 gives 1 by 30 R1. R1. R2 gives R2 minus 20 R1. So CG. So CD, WB, minimum ratio, WB by WJ. Here WJ equal to W2 over minus 300 minus 110, 110, 0, 0, minus M. Here W1, W2, S1, S2. Here, here, minus 300, minus 300. W1 equal to 1 by 5, 1, 1 by 6, 1 by minus 1 by 30, 0, 0. So minus M. Here to 4, 0, 20 by 30. This is the key element.